Good evening, everyone. Welcome back to another episode of the Space Roundup, and welcome to Space Door Live if it's the first time you're joining us. This is a show that Nick Howes and Terry Moseley, both space experts and astronomers, host every other Tuesday at 7:30 p.m., and they bring you the latest and greatest of space news. Hey, Nick. Hey, Terry. How are you guys doing tonight?
Pretty good.
Yeah, great. Good to be back.
Awesome, great to have you guys again on tonight. What do you want to give everyone a little taste of what's coming up tonight?
Rocks. We're going to be so behind me. You can probably see some cabinets. They're full of meteorites, and we're going to be talking about probably one of the biggest stories in UK planetary science history, with the witnessed fall and subsequent recovery of what's going to be known as the Winchcombe meteorite. So we'll talk about that, which is going to be a lot of fun. Go into a bit of the background of that and some of the story behind it. We're going to be chatting about what SpaceX have been up to with the SN10. Terry's got an awesome story about exoplanets, and I know Terry loves a good exoplanet. Yeah, just stick with us. We've got quite a few interesting little vignettes to go through.
Don't forget Percy. Don't forget Percy on Mars.
Oh, indeed. How could we forget Percy on Mars? But it's going to be an interesting show, I think. There's some really good stuff, and we've got props tonight as well. So there we go.
Well, if you guys have any questions in the audience, don't forget to use the comment section on Facebook or YouTube, and hopefully we can interact with Nick and Terry.
Cool. Nice to be back. How are you doing there, Terry?
I'm great. Good to be with you again.
Excellent. Right. Let's kick off then. What's the big story? Well, the Gloucester Meteor, or the Gloucester Meteorite. It's been called a meteor by various news agencies. It's a meteorite once it hits the ground. So a couple of weeks ago, we reported on, we all saw actually, something entering the atmosphere over the UK, and it was witnessed for over huge swathes of the UK. And the UK Meteor Observing Network, UKMON, and various other sites were basically set up to what's called triangulate this. So lots and lots of people had cameras in their back gardens. You can see footage from various security cameras, etc., that pick this thing up. So that also helps in terms of analysing some of the trajectory and analysing potentially where it broke up in the atmosphere. But the UKMON network, using a whole series of different radio instruments around the UK, were basically able to almost prove that this thing landed in a specific part of the UK, and that specific part of the UK was Gloucestershire. So I live in Wiltshire, which is in the southwest of the UK. Gloucestershire's kind of the next county up from me. So in terms of distance from me, if it wasn't in lockdown, this is not very far at all. This is only like 40, 50 miles away. Anyway, so they narrowed it down, and it was really funny. There's a radio show in the UK, Radio 5 Live, and they were talking about it the day after it happened. And they had various people on from Gloucestershire who'd phoned in and said, well, it's not here and it's not here. And somebody phoned in and said, well, I'm in Winchcombe, it's not there. Well, it was. It turned out that about 338 grams of this has been recovered so far, mostly from somebody's front driveway. So there's some fantastic pictures doing around to the internet at the moment of this kind of black sooty mass on this person's driveway, and lots of little meteorite fragments. And what the fragments look like is something like this. This is a meteorite called a Yende. So what's interesting about the meteorite that's fallen is that there's only been about 20 or so recorded falls in British history. So not many at all. And I know in Ireland, Terry, it's even fewer. There's very few. Yeah, there's very few meteorites across the entirety of the UK. So to get one at all is quite rare. To get one that's witnessed is incredibly rare, and then recovered, I mean, this is off the scale rare. It makes it even more interesting in that the meteorite is what's called a carbonaceous chondrite. So these are some of the most primitive materials in the entire universe. These are essentially very amino acid rich, not very rich in the metals that you'd normally associate with meteorites. So if you're going to go out, when lockdowns ended, with a metal detector or a magnet, good luck on that one, because you won't really find much. These tend to be packed with lots of organic material, sometimes quite a high percentage of water, and this depends on what class of carbonaceous chondrite it is. So you've got CX class, CV class, you've got various different what's called C class carbonaceous chondrites for carbonaceous, of course. And the beauty of this one is that, like Allende, this is the most studied meteorite pretty much in history. So this fell in Mexico in about 1969. And it was used a lot for some of the kind of analysis techniques that they were using on the Apollo missions. And it is generally regarded as the most studied meteorite, not just this one piece. This is about 48 grams of the whole mass. It's a much larger kind of meteorite. The thing with this is it's quite a small total known mass. You look at the images and the video of it coming in, and it doesn't look like it's more than a few kilograms worth. And basically you'll see it break up, you see these parallel streams coming in, so it's pretty obvious that it was going to hit the ground, looking at the trajectory, looking at the videos of the incoming bolide, as it were, the fireball. So the fact that they then went out and found it, and this is the interesting thing, we're in the middle of lockdown in the UK, if you're listening from any other countries. So lockdown, basically, we're not allowed to go anywhere unless it's absolutely essential. So essential travel is, if you can't work from home, you can go to work, but obviously based upon your own company's guidelines, you should not really be going out to the shops unless it's for essential food shopping, that type of thing. So the average kind of deluge of meteorite hunters who would normally go out, looking for this, thankfully weren't there. And the scientists who were involved, there was all sorts of debate. Is this legitimate use? And if you're a member of the general public and you're thinking, well, hold on, why are there dozens of scientists traipsing across field? How can they're allowed to do it? It's their job. That basically is their job. They're planetary scientists. And the beauty of this is that whilst they were traipsing across all these fields, they were looking at small black lumps on the ground, and most of it turned out to be dog feces, which I thought was brilliant. They were like, how many hundreds of pieces of dog feces? But they did find lots and lots of these small meteorites. There's one example. That's another one from Murchison, another carbonaceous chondrite. But then, like I said, the main bulk of it that they found was in this chap's the family driveway. And what's even more incredible about this, and again, given the current pandemic situation and economic situation that most of the world's in, the person whose driveway this landed in has donated the entirety of what was in their driveway to the Natural History Museum's Meteorite department. So if you were looking at a rare carbonaceous chondrite on the meteorite market, and the company I work for, we deal in meteorites. Carbonaceous chondrites can range from a few tens of dollars to grams to hundreds of dollars for a gram. So if you've got 338 grams of pristine condition, and that's the other thing, the quality of this material is so good. It's almost like a sample return mission, because the person who found it really treated it with care. They picked it up, with gloves and put it into foil wrappers and really did the right thing. And that's all the more amazing thing, is most people would pick it up and maybe shove it in their pockets. So you've got the whole kind of the lineage of this, from the detection, from the site, from the fact that the UK MON network and various other scientific groups and organisations, the UK planetary science community, kind of all got together to say, right, we roughly know where it is. We're going to go out. We're going to find it. We're going to hunt for it. And they did. And they picked up loads. And there's probably still quite a bit more to be found, because the thing with meteorites, when they come into the atmosphere and they start to ablate and basically break up, you will get what's called a strewn field. So it won't be just one meteorite landing. You'll get fragments dropping off all through its trajectory. So what typically happens is the heaviest part of the meteorite will come round, and that'll be at the kind of back end of the top end of the strewn field relative to where it came in. But then you'll get lots of smaller pieces, and you saw this with things like Chelyabinsk back in 2013, where it exploded high up in the atmosphere, and you were showered with these what they call peas, Chelyabinsk peas, small kind of pieces of it. So I'm guessing probably over the coming months, years, etc., there will be more bits found, small bits, and again, probably not as valuable to science as the bits that they've got now, because they've recovered it so quickly, and the weather thankfully hasn't been bad in the UK for the last few days, so there's no kind of major weather degradation, and it's already being analysed at the Open University and various other laboratories around the UK. So I think it's an absolutely fantastic story from a scientific point of view. As I said, if you're a member of the public and you're thinking, how did these people get out to go and search for it? What gave them the right to do that? It's science. So you kind of overlook it and think, this is really good. This is solid science. And my hat really tips to UK MON and everyone else who's been involved in this. I mean, it'd be lovely from a scientific viewpoint to get. I love meteorites anyway. I collect them. Got hundreds of them in cabinets behind me. To get access to some of this, to actually see it, and to get the data on it. But obviously, all that data is going to be published. You'll probably have Diamond Light, which is the big particle accelerator at the Harwell campus, doing all sorts of CT style analysis on it. Generating images that cut all the way through it without actually cutting it up. So it's going to be, I would think, fantastic. and it will keep scientists busy for years. I don't know, Terry, what's your kind of take on this? What are your thoughts?
Yeah, very much agree. By the way, I thought we were getting a video of this just in case anybody hasn't actually seen it. So I don't know if we can play that or not. But as you were saying, these are basically the most primitive objects that we will ever get our hands on. They date back right to the very beginning of the solar system. This thing is about 4.6 billion years old. And not only has it got all the organic material in it that you mentioned, but there are lots of other stuff that tell us a whole lot about how the early solar system formed, what its composition was. You were talking about pre-solar grains. That means basically it contains grains of material that came from other stars. They weren't part of the sun's own composition, if you like. So the sun itself obviously formed from material that was produced in other stars. So this is stuff that actually predates the existence of the sun and the solar system, plus the stuff that is there that composed the formation of the planets in the first place. Absolutely invaluable scientifically.
Yeah, and the fact out there, I would say, unless they have managed to find the entire mass. But I think it's beautiful, Terry, the pre-solar grains and these kind of nano diamonds that you sometimes find as well in these carbonaceous chondrites. But some of these pre-solar grains, they're dating back 7 or 8 billion years, as Terry said, way before the formation of our solar system. And the fact that these form, they estimate in quite relatively low temperatures. So a lot of the meteorites, depending on the class, can have up to 22% water in them, which is, again, it's given us such an insight into the earliest stages of our solar system. And there's various theories as to how life appeared on Earth. We still don't know how life appeared on Earth. Could it have been brought here by comets? Could it have been brought here by meteorites? We don't know, but it's really, really fantastic. And as I said, I cannot speak more highly of both the people who've donated this material. So if you ever listen to this show, thank you so much from the entire scientific community for being so incredibly generous with basically something that would pay off your mortgage. So well done on that one. But to the scientific community, hopefully we're going to get some fantastic science. And one day, we'll all be able to visit the Natural History Museum and probably see a piece of this in a lovely display cabinet at some point once Monica Grady and all of her team at the OU and various other people have pored over it for years. It's just a great story. I love it. And, coming from, I grew up in Wales, and we kind of have this famous story in Wales about a dog called Bev Gellert. Which is this kind of story dating back about 1,000 years about a prince who kills his dog. And I'll let you all Google it. I'm not going to bore you with that. But Bev Gellert is also interesting because it's one of the only meteorite fall sites in Wales. And I know Ireland, some of the people like KTEC, for example, in Ireland, they do fantastic work in terms of meteorites as well. So they're just great. And especially on cloudy nights, another wonderful hobby. If you get into meteorite collecting, which, I have in a massive way, and you start buying meteorites, even low cost ones, it's really, really fantastic. If you get yourself a little USB microscope, you get those for $10, £10 on Amazon. You can spend nights just poring over these meteorites at really close level and seeing all of the inclusions and fascinating structures in some of them. So it's a fantastic hobby, and it's cloud free as well. So if you cloud it out, you can play with meteorites all night. Really fun.
Yep.
So we've gone from what hit the Earth to possibly another Earth. This is Terry's big story. I love this one. Over to you, Terry.
Yeah, I'm fascinated by exoplanets, partly because they were basically the stuff of science fiction when I first got into astronomy. The only planets that we knew of in the entire universe were the ones in our solar system. We speculated, but we didn't know that there could be other planets around other stars, but we just didn't know. Now we've discovered over 4,000 of them, which is just absolutely amazing. And when you think of it, the nearest star is over 4 light years away, and a light year is about 9 million kilometers. And you're talking about something basically the size of the Earth up to the size of Jupiter, or sometimes smaller. To detect that at that distance, it was really just the stuff of science fiction. But there are a number of ways of detecting them, and this particular one was discovered by the Transiting Exoplanet Survey satellite tests. And what happens is, if the orientation of a planetary system around another star is just right, we see the planets as they orbit the star pass in front of it. And that causes a very slight dimming in the light from the star. Incredibly small, but we have incredibly sensitive instruments. And there are, as I say, a number of methods. Most of them have been discovered by this transiting instrument, particularly also a satellite called Kepler. This one was discovered by TESS. Now, that's interesting enough just to be able to work out the size of these planets, how many there are, how close they are to their star, how quickly they orbit, what their temperatures are, and so on. But the next leap in science fiction now into reality is that we can actually study their atmospheres. This one in particular is what we call a super Earth. It's a good bit bigger than the Earth, more massive, and it has quite a distended atmosphere. That's partly because it's relatively close into its parent star, a red dwarf star. So it's very, very hot, and that makes the atmosphere puff up. So whenever the planet passes in front of the star, we see the atmosphere actually altering the light of the star as it passes through the atmosphere. And we can tell quite a lot about that. So not only now are we studying planets around other stars, we're studying the atmospheres of other planets around other stars. This one is, as I say, about, they reckon about a good bit bigger than the Earth. Don't know exactly how big. Very close to the star. It orbits around the star in only 36 hours. Now, it's a small star, but even so, that's pretty quick. It's a red dwarf star. That has a number of other implications. It means that the star is probably subject to a lot of what we call flare activity, where it puffs off a lot of coronal mass ejections and flares and so on, which can affect the atmosphere of any planets going around it. Now, we're still in very early stages at working on this one, but we hope to detect quite a lot about the atmosphere of another planet, and that is just mind-blowing. We can study the atmospheres of the Earth and the planets in our solar system, of course. This is the first time we've really had a chance to study the atmosphere of an exoplanet. So that was one brilliant one. As I say, it's in early days yet. One other thing, by the way, it's probably tidally locked to the star. It's so close in that one face is permanently facing towards the star and the other side is facing away from it. The other one is an even more amazing story. It's what we call a rogue planet, a planet that is no longer attached to its parent star. And this one is a big bruiser. It's only 20 light years away, which is quite close in astronomical terms. We think it's so much bigger, even than Jupiter, the biggest planet in our solar system, that it's actually very hard to imagine how something that big could be kicked out of its own solar system. It probably was not ejected by the interaction of other planets, because it was almost certainly the biggest planet in that system. So it would kick other things out. It wouldn't be kicked out. So it was probably part of either a binary star system or a treble star system, or else possibly another star that passed very, very close to it and disrupted the system. So this huge planet, what we call a rogue planet, is careering through our galaxy. At the moment, it happens to be only about 20 light years away, and a number of amazing things about it. Not only is it so big, it has a very, very intense magnetic field, about 4 million times stronger than the Earth's magnetic field. And that's so intense that we reckon this planet has auroras, even though it doesn't actually orbit a star the way you orbit around the sun. And it's the sun that basically causes the aurora on the Earth. So 2 amazing stories about exoplanets. And if you Google exoplanets and sort of follow links, you can spend a week following up the amazing variety of things that there are. But those are 2 that really intrigue me at the moment. And I know you're interested in this too, Nick.
Oh, it's amazing. I mean, I worked many years ago on the Square Kilometre Array, and one of the key things they were looking at is exoplanet atmospheres and being able to detect, for example, some of the indicators of biosignatures in the planetary atmospheres as a potential for detecting life or maybe plant life, whatever, in the atmosphere. There's so many interesting points on this. I mean, 20 light years. This rogue planet is interesting in that we're surrounded by, going back to the asteroids and the comets, we're surrounded by the Oort cloud, the Kuiper belt, the asteroid belt, etc. So Oort cloud at around about a light year away from the Earth. Something throughout history has potentially disrupted that. We may have come, as we traverse around the galaxy every 250 million years near to other stars. But if you've got these rogue planets and things like Oumuamua, the pronunciation still eludes me, but the big thing that was causing all sorts of controversy because somebody said it was an alien spacecraft, but let's not even go into that. So this exocometry body that was detected, this kind of transiting body, these things, when they go through the Oort cloud, and if you've got large planets like Terry was saying going in that part of the sky, you're going to get disruption, which could potentially fling in hundreds of comets in towards the inner solar system. So that's quite terrifying. I think when we've got things like the ELT, the James Webb Space Telescope, etc., then this capability is going to only grow. You look at TESS, you look at the Kepler instrument, for example, and the amount of transiting exoplanets and the way that they're doing it via Doppler shift and measuring light curves, the sensitivity, as Terry said, if you've got a really powerful light bulb, basically just put a P in front of it and see if the light dims from that light bulb. It's, and that's not even near the scale of magnitude that we're talking here. It's quite incredible what they're looking at. And obviously, as well, as the planet orbits around the star, you're getting this slight wobble in the star caused by the planet's gravitational pull on the star because they're interacting with each other. So these detection methods, we've been able to now for several decades to see these exoplanets, but now we're honing in more on the atmospheres. And at some point in the future, we're going to get probably quite detailed spectroscopy on the atmospheres, which may be an indicator of life. The problem we've then got is, then what? The nearest star system to us, the Proxima Centauri Alpha Centauri system, is around about 4.3 light years away. At the current technological level we're at, that would take the fastest spacecraft we've ever made 11,700 years to get there. So we're going to need a kind of giant leap. People say quantum leaps. Quantum leaps is completely the wrong term. Quantum leaps is the smallest possible step you can make. But we're going to need a giant leap in terms of technology to be able to really study these. And there's all sorts of talk about these micro pico satellites riding on light beams, essentially like solar sails, to go out there in possibly 1/10 the speed of light, so maybe a 40-year kind of arrival time. But then you're looking at 40 years to get there, then 4 years for the signal to come back. And this is not going to be an orbital mission, because how the heck do you slow down something traveling at 1/10 or 4/10 the speed of light, for example? It's going to be next to impossible. So, we are into science fiction land as to what we do next. But this ability, if you've got things like SETI that's been listening out for, potentially alien civilizations for decades now, and unfortunately not really picking up anything. I've always thought, probably for the last 10, 15 years, that the detection of interest in planetary atmospheres is going to be our best shot at this, because we've got so many, as Terry said, there's thousands, have been detected now, and some of them are reasonably close. Even in the Alpha Proxima Centauri system, we know that there's exoplanets. So, and I think between that and our next story, where we're coming a lot closer to home, I think this "Are we alone in the universe?" question, is only hotting up now. And hopefully, between the discovery of these amazing meteorites and the discovery and work on the exoplanets and what we're going to be talking about next, there's so much going on. It's such a great time to be into space science at the moment. Anyway. Yep. So moving on to our next story, Perseverance, the rover. It's on the move, unlike us. So it's driven more than we have. I don't know if you've got any thoughts on that, Terry. But
yeah, I'm sort of reluctant to call it Percy. It seems a bit demeaning, really. Perseverance was a name that was chosen very, very carefully, and hopefully it describes it pretty well. But Percy will do for now. Yeah, a number of interesting things on this. They have now named the landing site, which is something that they do after a while at most of these rover and lander type sites. They've named it after a science fiction writer, which is interesting, Octavia E. Butler. So it's now the Octavia E. Butler landing site. And she's a black female writer, a science fiction writer in America. So it's good to see that being recognized. Now, this first drive wasn't very much, 6.5 meters. And It took place over a period of 33 minutes, so it wasn't exactly breaking any speed limits. But basically, they're just testing it out at the moment. I mean, this is not like taking your dad's car out for a spin, you know, when you first learn to drive and you prang it into the gatepost and has to take it to the garage to get it fixed. You don't want to break anything on this. If you do, that's it. And you'll not be terribly popular among your colleagues, and you'll have just wrecked several $1 million worth of equipment. So they go very slowly, very carefully. They make sure that everything is working and that it won't interfere with anything else when it works. And whenever two of them are working together, they won't interfere with the third system. Very, very careful, which is why, for example, they won't be flying the helicopter for at least 30 to 60 days. But anyway, so far it has worked very, very well. They drove it about 4 meters forward. They then turned it through, I think, about 150 degrees or so to the left, and they then backed it for another 2.5 meters, and everything worked perfectly, which is the main thing. So far, all the systems are working, certainly everything that they've tried. And the main function of the rover is to go and collect samples. We'll talk about that probably a lot more later. Store them in little sealed capsules and caches, which will then be picked up and brought back to Earth, hopefully by another mission in a couple of years' time. To me, the most fascinating thing is the idea of flying a helicopter on another planet. And that is another thing that they will be doing very, very, very carefully. It was stowed on its side onto the rover. So far, they have partially deployed it. They've let it down. They're starting to power up the batteries to make sure that the batteries are working okay. And whenever they're sure that everything is ready, they will be driving the rover to a nice flat spot with no rocks or stones or anything on the ground, putting it down carefully on the ground, and then driving away and leaving it sitting there. And then it will start to undertake its own autonomous commands. At the moment, it's being powered up from the RTG, the power source on board the rover itself. It has solar cells, and eventually it will be relying totally on the solar cells for its powering for flights. So again, the first flight will probably be just a very, very short test flight to test all the systems. After that, it'll be going out and searching for interesting things for the rover to go and investigate. So far, so good. And, you know, they have a pretty good record once they actually get a rover on the surface of Mars. Most of them have greatly exceeded their design lifetime and done much, much more than was expected of them. And we can only hope the same for Perseverance. What about you?
Absolutely. And the thing is as well, they've had to do a redesign, fundamental redesign on the wheels, obviously, because with the last rover, hugely successful as it still is. I mean, it's been trundling around now since 2012, but it got hammered. Those wheels got hammered. So again, this whole checkout and, you know, scoping the area, looking for somewhere to drop the helicopter, to drop Ingenuity on the ground so it can have a safe takeoff, and obviously not kick up too much of a mess. I mean, hopefully the planetary atmosphere on Mars is 100 times thinner than the Earth, so it's, you know, it's not going to do a lot of disruptive kind of helo style mess, helicopter style mess on takeoff. But it's really critical to get a good takeoff site for it. So that's one of the things that they're scouting out at the moment. Some of the rocks even nearby have been incredibly fascinating. As Terry said, systems check out. If you've been working as a systems engineer on this, you've probably been working for the best part of 10-15 years on this mission. You know, conceived pretty much, you know, around about the same time as the last rovers, and obviously with the whole intent of developing this sample return mission concept. So integration with the European Space Agency, with the Rosalind Franklin rover that's coming in a few years, and, you know, then an orbiter, again provided by ESA, and hopefully bringing the whole lot back to Earth in the early 2030s to have some pristine Martian samples, as it were, which would be the first time anything's been recovered from the surface of Mars. That would be totally incredible. On top of that, we've obviously got Tianwen-1, which is orbiting Mars at the moment, the Chinese mission, which is going to be dropping its rover in a few months' time. That's going to be doing some fantastic science as well. The other interesting thing with this is the amount of data that you'd normally get back from deep space spacecraft can be quite limited, obviously, by the comms link. But now we've got such a flotilla of orbiters going around Mars and they're all helping. I mean, ESA are directly involved in this in terms of data relaying, etc. You got the Deep Space Network, the multiple Deep Space Network telescopes being able to pull in so much data, and upgrades on the DSN recently completed down in the Parkes Observatory down in Australia. Again, fantastic. And being able to get all this high definition video and staggering amounts of data. As Terry said, they're going to be producing, they've got the core drill on it, they're going to be drilling subsurface, doing analysis there, but obviously then caching these samples. And again, it's great to see British companies, Thales Alenia, obviously a massive European entity, but we've been talking to their offices in Belfast about some of the work that they're going to be involved with, not only in the Lunar Gateway, but in this mission as well, with the potential for sample recovery in the future. So it's just a story that's going to keep growing. It's unfortunate that MSL, last rover Curiosity that landed in 2012, its scientific goals, I mean, after the whole hoopla of it landing so incredibly with the sky crane, that they've now obviously gone a 2 for 2 and proved it works flawlessly again. And it was also really fascinating. I don't know if anyone saw the videos after the landing that were coming out, where you saw the sky crane, basically its explosive landing site, as it were, where it crashed off in the distance, and these clouds coming up. And this is the kind of level of data that's coming back from these missions, that, and they call them pixel jockeys, or kind of pixel hungry people who they want the next image and they must have the next image. And you've got to give the scientists time to look at and analyze what they're bringing in themselves. And there's going to be so much scientific data that won't be of interest to the general public. But I do love NASA's whole take on, here's an image, here's a video, and we're going to just show you. And the laugh that they had with the parachute, where they encoded a secret message in binary, and the fact that they've got the little Ascent of Man image of all the rovers on the plates as well. There's so much in this. The PR side of this mission alone is invaluable, but the science is going to come out in hopefully the next few months, years, etc. It's going to be mind-blowing, and there's yet more to come. And we fingers crossed that in a few years, European Space Agency will finally land something successfully on the surface of Mars, like they did with Huygens. I mean, ESA have done some incredible things with the Huygens mission on Titan many, many years ago now. Still the farthest human-made object ever put onto another planetary body or moon, which is incredible. And obviously the work with Rosetta. So big fingers crossed, because for this whole sample return thing to work, every single bit's got to work. So
there's one other interesting thing. Sorry, cut across you. They've actually done a software upgrade on it remotely. It has a limited amount of computing power, because people say, why haven't they got a modern high performance processor and so on in it there? The whole system was actually designed, 10 years ago, and you can't go changing it as you go along. So it's basically an early Apple iPhone system.
It's a G3. It's an Apple G3 processor.
Anyway, so it has limited capacity. So what they did was they deleted a program that they had installed in it, which controlled its landing, because obviously they don't need that anymore. That freed up a bit of space, and they have now uploaded new software which will help it to do its scientific task a bit better. So that's a neat little angle. You get a software upgrade set over 140 million miles or so, something like that. Brilliant stuff.
It is, and as a software test engineer, because that's kind of part of my day job in the space sector, let me tell you, this is hard. And if you get code wrong when you're firing code over that kind of distance, or you get one line of code wrong, things can go spectacularly wrong. Yep. So again, massive hat tip to all the teams at JPL and various other organizations that have worked on this. And in the UK, we've got companies like Sysys and CGI. CGI now owns Sysys, who've done fantastic work in this domain for many, many years. And we're not looking at fancy graphic code and wonderful what they call IDEs, development interfaces, using fancy new languages. This is really low-level programming, and it's absolute heart. And as Terry said, it's an old processor. It's essentially an Apple G3 processor going back quite some years, and they have got a limited amount of memory. But if you think that the Apollo guidance computer, the thing that got us to the moon, landed us on the moon 6 times, was about just under 80 kilobytes of memory. If you've got good programmers, you've got good programmers. And these people at JPL, NASA, and various other centers, European Space Agency, etc., these are some of the best software engineers anywhere. So yeah, huge. And performing software upgrades. That's the beauty of this system, is the autonomy as well. The fact that you've got a 12 plus minute round trip time, as it were, or light time between Earth and Mars. So you're not going to be driving this thing kind of real time. You've got to rely on the system's autonomy. It's got, you know, various hazard avoidance cameras, all sorts of things that they need to work. And if they don't work, things go very, very wrong. And we only have to look at, you know, the European Space Agency Schiaparelli and the computers,
Yep.
you know, the issues there where it thought the radar was saying it was this height and various things didn't work. And this happens to so many missions. It happened to the Indian attempt to land on the moon, the Israeli attempt to land on the moon. There's been all sorts of problems. So,
Yep. Nick, there's a question there you might want to answer.
Right, so Linux. So for
Yeah.
all of you computery nerdy geeks, most of us run Windows operating systems or Macintosh operating systems. And Macintosh is based upon a Unix distro, a BSD distro going back quite some time now. Linux is a kind of open source, and a lot of the space sector runs on open source code. So this is code that gets published on the internet to places like GitHub, which is a common repository where people will put their code up and let other people have a play with it. And Linux as an operating system, there's various flavors of this. There's Ubuntu, there's Red Hat, all sorts of different flavors of Linux. I run multiple Linux systems. I've got Raspberry Pi computers, Ambasat small development satellite systems, lots of different laptops that I use for my day job. And some of them we do run Linux systems on. We do a lot of work, for example, with the UK Defence Forces, where the onboard systems are Linux-based. And it's quite amazing to see Linux as an operating system. Well, essentially, they can shoehorn it into anything. And if you want to get really optimized code, you typically write in languages like C, C++, which are quite old languages now, or even assembler language, where you're literally going into the heart of the computer itself, where you're not using a high level language where you've got English language. You're literally going in with really low level commands, and that tends to write very optimized, very fast running code. With the Linux operating system, some of the real-time core versions of Linux you can run space missions on. There's a core flight system which is freely available from a company called Ball Aerospace, and they've got a system called Cosmos, which has got almost like a full satellite simulator integrated into it that you can use to control, you know, your CubeSat. If you're a university or whatever building CubeSats, these kind of things are totally viable. I think it's PC 104, which is a standard board now on CubeSats, coming out of companies like Clyde Space up in Scotland. Again, this is all based upon, you know, open standards and open coding practices. And there's a company in the UK called KISP Space, are really big on the whole standardization of open source components, almost making spacecraft Legoized as a way so you can build them. And yeah, it's a fantastic question, this. Definitely want to go into more if you're really interested in the software side. Going back, as I said, to the days of Apollo and the Apollo guidance computer, which was the first time any software code had ever been written that literally people's lives depended on. And you got people like Margaret Hamilton, Don Iles, various other people who worked at, you know, the MIT Instrumentation Lab, and you know, under Eldon Hall and people like that, going back into the 60s, and the development of the DSKY and the AGC, really, really interesting. So if you're in any way at all interested in the kind of history of computers and spacecraft, start there and work forward, and then you'd be amazed how small the code lines are. You think that the Hubble Space Telescope's 500,000 lines of code. Modern operating systems, it's in the hundreds of millions of lines of code. So as I said, these guys and girls, and it's not just men, it's lots of women. One of the best software engineers in the early days of Apollo was Margaret Hamilton. She's one of the most recognizable figures. Her daughter was one of the world's first software test engineers when she broke something on the DSKY, and they were like, we need to fix. Well, actually, good story with this one. So Margaret Hamilton's daughter, because they didn't have crashes and like home caring and all that type of thing in those days, she used to bring her daughter in to work with her, and she accidentally bumped into some of the buttons on the DSKY, which is the interface that they use for controlling the Apollo command module. And she pressed some commands and put it into what's called the POO mode, Program 00 mode. And they were saying, oh, test pilots wouldn't do that. But Margaret Hamilton essentially wrote some code that would get around this problem. And lo and behold, on Apollo 8, when they were coming back from the moon, the first time they'd ever been to the moon, that command was accidentally triggered. So being able to circumvent this and get around this with such a limited amount of memory and such a limited user interface, it's amazing. It really is amazing. So CubeSat network, yes, let's do that. Let's do that. There's some really fun stuff. If you've heard of a company called Ambasat, AMBA-SAT in the UK, they're doing some great stuff with small. I've got one right here. This is a a full satellite in a box that they're selling via Amazon, and they're these tiny little Pico satellites. They only stay up for a few weeks, but yeah, loads and loads of fun. Could not recommend this more. It's such a fun part of my day job and what I do. So but let's move on, because we're burning time and we still got some more stories to go. Next story, talking about software engineering. In the software engineering world, there's a terminology known as agile. So this is essentially you build fast, you test quickly, you iterate very, very short cycles. So 1 to 2 week cycles. You write a load of code, you test a load of code, and you essentially, if it breaks, it breaks. If it doesn't, great, you move on, and you keep iterating and iterating and iterating. The space industry hasn't really worked like that for most of its life. The space industry has been very conservative, and this is how we do things. This is how, they use what's called more like a waterfall. So they'll develop something, either hardware or software, and they'll go through. And in the early days of Apollo, yes, they were testing the code a lot, and it was incredibly complex because it was all hand wired. Some of the microprocessors and circuits, it's really primitive stuff. So you're literally, if you look at the wiring of the Apollo guidance computer, it's the biggest spaghetti mess you've ever seen in your life. It was just an absolute nightmare. And literally, little old ladies used to wire it. They got expert seamstresses who would wire this stuff, and then they'd use a computer to kind of make the interconnections. So SpaceX have really adopted this agile methodology. They are not afraid to fail. They're not afraid to make mistakes. They learn by their mistakes, and they iterate really quickly. And this was demonstrated literally in the last week with SN10. So if you've been following us for the last year, we do like to talk about SpaceX and their SN models. So going from the little grain silos that go up a few hundred feet up to like the big tests that they're doing now with the Starship and the Super Heavy that's to come. Super Heavy's being built. That's kind of like the main launch platform, as it were, which Starship will then sit on top, and that's what's going to go to the moon and Mars, etc. And if anyone says it's not going to go to the moon or Mars, it will. Do never, ever, ever, ever bet against SpaceX, because you will lose. They are simply just progressing at a staggering rate. So SN8 blew up on landing. SN9 blew up on landing. They just went, okay, let's crack on. They had SN10 already in what's called the high bay. They were already, basically, it was built and ready to go. They had them almost side by side during the SN9 launch. SN10 was incredible. It was the first time in human history anything like this had been achieved. They've been doing it with the Falcon 9 and the Falcon Heavy, where they land the course. This time, this is a whole other kind of scale of magnitude. By the time this thing is complete, it's going to be the size of a Saturn V. Now, the Saturn V is still the largest rocket in history. 7.5 million pounds in weight, 363 feet high, generated enough energy to power the entire United Kingdom for the first 1 minute 40 seconds of launch with the F1 engines. I mean, it was generating something like 67 gigawatts of power on launch. And this is 50 years ago with these rocket-dying engines. Now with the SpaceX Raptors, what they've got is this, it's incredible. They've got this hot fire capability. So whilst most other space companies, if they have to call an abort, essentially what they'll then have to do is stand down, maybe drain all the cryo fuel and drain all the fuel from the rocket, do whatever repairs are needed, maybe wait a few days, refuel the rocket and try again. SpaceX, they got to T-0 on this launch and fired the engines and then shut down because there was some issue with the fuel pressure, etc. So, okay, they shut down. And everyone's thinking, oh, that's it, scrub for the day. No, they just went, okay, well, we've had this problem, but because the engines are designed for this, refire, launch, land, refire, they were able to fire those things back up in a matter of hours. So several of the online YouTube streams, so Everyday Astronaut's one of my favorites, they were covering this all day. They'd run for 8 hours, and they showed this hot fire, this kind of hot fire, almost like a static fire, although it wasn't. It was supposed to be a launch, and it shut down. And then it was like, okay, what are we going to do? They waited for another 2 to 3 hours, and then off it goes. And that is astonishing in itself. The fact that it then landed, so this thing goes up, like, I think it was 6.5 kilometers, forgotten the exact height it went up, does this incredible belly flop maneuver, comes down where it's got as high an atmospheric drag as it can. It's got these fins on the side that kind of slow it down. As it's coming down towards the ground, you've then got this almost like, it was like I'm watching a Marvel Avengers movie. The sci-fi nature of the footage as it was coming into land from the underside, from the SpaceX coverage. And it did this kind of flip maneuver, and you can see the engines burning. You're thinking, this is science fiction. This is incredible. And then comes in and lands and sticks the landing. However, there was a little fire on the base, and you could see that it hadn't quite landed vertically. It was like the Leaning Tower of Elon, as it was known at the time. It was slightly tilted. And then it was really funny because SpaceX then cut their coverage. It's like, oh, we've landed. That's great. Bum, bum, bum. But the other YouTube streams carried on, and they were talking about it. And every astronaut, it was really brilliant watching him because he's like talking, not even looking at the spacecraft, talking into camera. And then all of a sudden, boom. So the rocket basically had a methane leak, and there was a fire going on. They sent the fire trucks in to try and douse it down and stuff. But essentially, it took off again. It blew up. It went up about 50 feet and then came back down in this absolutely spectacular explosion. And what does Elon do? He goes, yeah, successful test. It was. They landed, they launched, they did the belly flop, they landed. Fantastic. Absolutely amazing. And whilst everything to do with Starlink I hate with a blood passion, everything to do with Starship is just, it's mesmerizing to watch. And that's it. Terry keeps saying I need Valium when I talk about this, but it's just amazing.
Life is never boring whenever you're watching anything to do with SpaceX. What amazes me is that they basically steer it down. You call it a belly flop. It hasn't gone up absolutely vertical. It takes off vertically, and then it starts to curve over to send the rocket onto an orbiting trajectory. So it's already quite a few kilometers, I would say. I'm not sure about that, but a considerable distance from the landing site in terms of its horizontal displacement whenever the first stage cuts out and has to come down again. So they sort of steer it down using those fins right back exactly to the landing pad. And then, as you say, it does the flip, ignites the engines again. And another thing that's amazing is watching the engines cut out as it goes up. They cut out one, then they cut out the second one, and you can see the gimbals altering the thrust angle to keep the thing going straight. Then they light them again on the way down. Absolutely amazing. And, okay, it didn't end well at the end, but as you say, the actual flight part of it was brilliant. Just total success.
That's it. And SN11, they're already prepping. Yeah. SN11's going up next week. Yeah. They are not holding back here. They just keep going and keep going. And SpaceX right now are the absolute dominant force in the entire global space scenario. If you're a Western organization, launching with anyone else right now, unless you've got a very specific payload, between SpaceX and what Rocket Labs and Peter Beck's team in Rocket Labs down in New Zealand, again doing phenomenal stuff, and they're looking at now how they can do recovery. But all the major space agencies have just been left for dust. Ariane Space, their launch schedule for this year, it's 5 or 6 rockets. Obviously, you've got the big one with the James Webb Space Telescope, because you need a massive fairing for that. But the way SpaceX are conducting their business, they're absolutely cleaning up. They are destroying the competition. And I just can't see anyone else catching up at the moment in terms of their economic model, etc. is so powerful. My only concern, and this is a big concern, rockets do fail. They still even get Falcon 9s, which will occasionally fail. I mean, they nail the landings now pretty much 96% of the time, but not every time. If you've got something the size of Starship coming in to land on Mars with a crew of potentially several dozen people, is one of the things that they're planning, and something like what happened with SN10 happens with that mission, you've got no recovery. You've got an unholy mess, obviously, millions and millions of miles away on Mars. And that kind of accident, we need to kind of almost prep ourselves. As a species, as humanity itself, we need to get ready for when something's going to fail. Mm-hmm. We almost had it with Apollo 13. Apollo 8, when it first launched, they were going to orbit the moon at Christmas. And one of the big discussions was, well, if it goes wrong, that thing's going to still be orbiting to this day. potentially if they'd have had an engine fire problem, whatever, they could have been stuck in lunar orbit until they died. And then every time you look at the moon, especially near Christmas, you're looking at 3 dead astronauts. Thankfully, that didn't happen. Apollo 13, incredibly close in terms of, the story of that is so well known, and the incredible work that the mission control team did in terms of getting them back. At some point, and we've had disasters in space, we've had Columbia, we've had Challenger, the Soviet Union had multiple issues with various space stations and re-entries, etc., and Komarov, and it's going to happen, and we need to be aware of this. Now, the question is, do we stop and wait for years while we do accident investigations and all the other things, or do we move on? If a car crashes, we don't stop every car from driving. If a plane crashes, we don't typically stop every plane unless it's Boeing and the 737 MAX, and you've lied about your data and you've crashed multiple ones. And yet then, yes, you suspend everything. The 777, I think it's a 777, they had an issue with an engine fire, pieces of it dumping over the United States a couple of weeks back. You've got to take accident investigation seriously. But if we were to stop for years on end while we do this, then is that going to affect our timeline for exploration? And that's the thing. It's not so much getting tourists into space and all the other things. And that's going to happen. And be aware, there will be a tourist accident. Virgin Galactic, we were talking about Virgin in a minute, but Virgin Galactic, during one of their flight tests, unfortunately, the co-pilot died in a flight test, and the pilot, seriously critically injured because of the feathering issue with the feathering wing system. So we've almost got to be aware that this at some point is going to happen. But right now, just watch them. If you don't, there's hundreds of thousands of people watching these YouTube streams, and it's just amazing. It's really fantastic to watch. And as I said, I hate Starlink pretty much more than most people alive, because of the unholy mess that's going to create. And we can talk about that at length. Not just them, but all the other constellations that are going up there. It's not so much Starlink with the orbits, but OneWeb and various others. Is going to be some all sorts of hell to pay at some point in the future. But with what they're doing with Starship, again, massive hat tip, brilliant stuff.
Yep.
Go on.
No, I was just going to say, Elon, you can both love him and hate him.
You absolutely can. And that's the thing. As an engineer, you've got to admire him. You can't say that his engineering prowess and his team, it's not just Elon, obviously, it's the incredible team of people he's built. Working out of Hawthorne, working out of Boca Chica, etc. These are seriously good people. Anyway, our final kind of story for this week is the future of UK spaceflight. So, whilst we're still waiting in the UK for a lot of the regulatory framework, and I'm involved and my company's involved in quite a lot of the work on this, in terms of you're dealing with lots of different angles for this. You've got the range safety regulations, you've got the maritime safety regulations, you've got the environmental safety regulations. You have to introduce the nuclear commissioning group, because if some of the payloads, you may have small RTGs. There's a whole ton of different things that you have to do in health and safety executive, all sorts, and tick all these boxes to make launch from the UK viable. And it's a big, big task, because you're looking at, with Shetland, obviously quite a remote launch location. It's going to be very similar to what they've got down in New Zealand. As I said, Peter Becker and his Rocket Lab team, what they're planning with Shetland is very, very similar. And ABL and Lockheed Martin are working on this, and Lockheed have commissioned ABL to do this kind of rocket in a box system, which is going to be really interesting and fantastic, and all of the infrastructure that's kind of surrounding that, and what you do with tourism, and how you keep people safe distances away, and how you monitor the environmental impact if you're launching rockets and one of them blows up or goes into the sea or sets fire to a massive peat bog, as could potentially happen with Sutherland, because the Sutherland site, which is another one of the key launch sites, is in the middle of a triple SI peat bog location. Peat is incredibly combustible, so you've got all these issues. One of the interesting ones, though, is how Virgin are doing this down in the Cornwall Peninsula. So Cornwall's been decimated, as we've said many times, by COVID, tourism, etc. And the people involved in that, Miles Card and various other people, he's moved on to work with Falmouth now, but there's some really great people. Melissa, who's now heading up Spaceport Cornwall, really, really great team, and they know what they're doing. And they're working with the US Virgin Orbital Office, because don't forget, Virgin everyone goes UK launch. The UK launchers are American launch vehicles. Even though the UK does a phenomenal amount of work in small satellites, we dominate the small satellite work with SSTL, satellites, with Clyde Space, various other organizations. The launch vehicles themselves, so Cosmic Girl is Virgin Orbit, which is a US company. The Launcher 1 is a US rocket. It's governed by what's called ITAR, which is the International Trade and Arms Restrictions. And there has to be special, what's called TSAs, technology safeguard agreements, and that will basically mean that US staff have to be on site, it has to be very secure, etc. All these things really take time, and that's going through UK Parliament as we speak, slowly but surely. And obviously they've got bigger problems at the moment with COVID. What's come out now is that Virgin are seriously considering, and I think there's some real mileage in this, in the Virgin Galactic offering for the UK. So if you've got, and this was always kind of off the cards, I know we're going to use, Launcher 1, it's just going to be for kind of orbital launch vehicles with relatively small payloads. But the fact remains that in the UK and all around Europe and, all around the world, there are people who've not been affected by the pandemic. You look at Jeff Bezos, his wealth has increased by 60% during the pandemic because, everyone's moved to online shopping. So there are very, very rich people who like to spend money. And if you've got 120,000 quid burning a hole in your back pocket, going into space is one way to spend that money. And if you wanted to, having, say, the White Knight system and, Virgin Galactic in the UK or a European launch site is one way to do that. And it would generate, in my opinion, a huge amount of interest for tourism in Cornwall, and we're bringing people from far and wide and spark a whole new tourism industry, because Cornwall's beautiful anyway, so you can go down and you can visit the Eden Project and Lost Garden to Heligan and all sorts of places down there. But it's really interesting what they're doing here. I don't know, Terry, what's your take on this?
Yeah, I agree totally. I just think it's amazing that after I think it was the Wilson government way back in the 60s, which sort of more or less killed the UK space program, that now we have a government, whatever you think of them in other respects, is actually now advocating and promoting and supporting the UK space program. So just, wish them all success.
Yeah, it's really interesting because the UK is hosting what's called the COP26, the big climate conference, towards the back end of this year. And one of the key themes for that is what's happening. Scotland is doing so much work on the space side. You've got this almost like a Silicon Glen area across that lower part of Scotland where you've got Orbex, you've got Clyde Space, you've got Skyroria, all these different kind of launch companies and integration and satellite development companies doing incredible amounts of work in that sector. And again, launching from Scotland. And if anyone's been following the whole debate in the last week about the Scottish First Minister and did she break ministerial rules, etc., Nicola Sturgeon, the Scottish First Minister, seems to be able to weather any storm. She is, perceived by most people outside of Scotland, and I know there's all sorts of issues with people in Scotland as to what they think of her or not, but she's perceived to have steered a really steady ship through COVID. And, make no mistake, there is going to be probably a landslide victory for the SNP unless something catastrophically goes wrong. And at that point, they're going to trigger devolution. How that affects UK launch when Scotland is no longer part of the UK is a whole other ballgame, because those TSA agreements are between the United Kingdom government and the US government, not between the Scottish government and the US government. So it's an evolving story. That's all we can really say about it. It's one to watch. And I love this. I absolutely love everything, that's going on up there. So that's been our kind of whirlwind tour of all the news. We've talked about meteorites, we've talked about SpaceX, we've talked about exoplanets, we talked about, launch from the UK. We're going to round up with what's up in the sky. What can you actually see? And this I'm going to hand back to Terry, because he loves this stuff.
I'll go through this very quickly because we have overrun quite a bit. We've talked a lot about Mars. I always think it's amazing to go out and look at it and say, okay, there are so many spacecraft there orbiting it and on it. And a good chance is to go out on the evening of the 19th of March and everybody can identify the moon. And the moon will be very nicely placed between Mars and another star, or a star, which is approximately the same brightness and approximately the same color, Aldebaran. It'll be interesting for you to try and guess which of those is actually the brighter. And if anybody wants to do that and report back in 2 weeks' time, we'll let you know. So if you're not sure where Mars is, that's the time to find it. Also note that because it is now much, much further away from the Earth, it is an awful lot dimmer than it was whenever we were seeing at its best back in October. And one final thing, this is for those of you that have the opportunity to go to or live in an extremely dark part of the country, well away from any city or town or artificial lighting. The zodiacal light, you need to Google it. I haven't time to explain exactly how it is formed, but a chance to see it is from now until the 16th of March when there's no moonlight. You need a very, very dark sky and a clear horizon right down to the western horizon. As I say, use the internet, go and see what it's about. Basically, it'll be a faint cone of light extending up from the horizon towards Mars. Very difficult to see. If you manage to see it, you've got exceedingly good skies and you're very, very lucky. So that's really all I can say at the moment.
Yeah, I mean, in Ireland, as Terry knows, you've got places like Skellig Michael, which is it's where they filmed Star Wars, the last Star Wars movies. It's a beautiful dark sky location. In the UK, we've got places like Kielder Observatory in Kielder and the whole Galloway stretch across that kind of area extending from Newcastle over to the Glasgow side of Scotland. Obviously, we've got down in the Exmoor kind of area and the Norman Lockyer Observatory, great people down there as well. Near me in Wiltshire, it's all recently been designated to be a dark sky reserve. So, and I'm quite lucky. It's a good story associated with this, which some of you who've followed me on Twitter may have seen. So I've had a few run-ins with my local council, which is Wiltshire Council, over the past, however many years in terms of light pollution, but they've been generally very good. I do live in quite a good dark location. Recently, they changed the street lighting near me to LED lights. Now, whilst LED lights are technically more efficient and cost less to run, which is all fantastic, they're a broad spectrum. Unlike the old orange sodium lights, if I had specialized filters, which I use on my telescopes out in the observatory in the garden, you could filter out the light, so you could image in specific frequencies quite easily. But these broad spectrum lights, much harder to do. So when they fitted these lights, it was like, okay, who's turned on the moon? As it were, literally, my kids were saying, where did that light come from? It was like almost like a full moon. It's horrendous. So getting in touch with the local council, thankfully I got to speak to somebody who really knew his stuff, a real expert in terms of lighting, and we talked about spectral response, and we talked about all sorts of light curves, etc. And he said, right, okay, I'm going to try something. And they fitted these baffles which are shield baffles to all of the LED lights in my village. It's now pitch black. My back garden has never been so dark. I've gained at least a magnitude to a magnitude and a half. It's astonishing what they've done. And again, lots of people have asked me how I did it. Just get in touch with your council, be nice to them, be polite with them, give them the right data, speak to the right people. Hopefully you'll get the same result. It's absolutely wonderful once you can get it. And again, hat off to the local council for listening and for doing such a great job. So, and on that note, I'll hand you back to our hosts at the Space Store. As I said, please support the Space Store. Everyone's going through difficult times. Space Store have been shut now. They have a physical shop in the Didcot area, which is very near to the Harwell Space Campus. They've been doing some great work. They do some great outreach there. They do all sorts of different virtual reality tours and all sorts. They haven't been able to do this for the best part of the last year, which is tragic, really, because science, STEM, and outreach. This is why Terry and I do this. We do this for free. We do it every other week. We do the prep on this, and it's to try and do outreach to the public, and we love doing this. But supporting the Space Store, go and have a look at what they're doing. They do a cracking range of meteorites, actually. So if you're interested in meteorites, Space Store got meteorites. Just support the smaller guys, the small community shops, etc. Absolutely, they're invaluable. And the team, the two people that help us with the show every week, Latch and Luke, behind the scenes, again, they're great people, and they're doing this all for the love of doing it. So again, huge hat tip to them from, I guess, myself and you, Terry.
Yep, absolutely agree. Yeah, support the local, not only local business, but local enthusiasts that share the same passion as we do for astronomy and space.
Absolutely. So yeah, we'll be back in a couple of weeks' time, which should be interesting because there's other stuff happening that week as well. But we'll tell you about that closer to the date on the 23rd of March. And back to our dear friend Latch.
Okay.
Thank you so much, Nick and Terry. It was another incredible roundup. We've got some great engagement from Ground-Based Space, St. Alex, Daydream Astro. So thank you, all of you guys, for joining us on YouTube. I hope you guys enjoy that. I know I definitely did. Another thing, if you're heading over to the Space Door website, remember we've got 10% off everything for British Science Week until Sunday. So go over, check out our great range of meteorites and all other some great space goodies we have on there. If you didn't tune in last week on Space Door Live, we were actually speaking to NASA record holder and former astronaut Michael Lopez Alegria. So go check out that talk if you haven't already. And a little bit of what's coming up this week on Space Door Live. This Thursday at 7 p.m., I'm going to be speaking to the founder and former CEO of Oxford Space Systems, who are one of the sponsors of tonight's show. So I'm super excited for that because we're going to dive deeper into the entrepreneurial space journey Mike Lawton has had. So tune in 7 p.m. this Tuesday, same time, YouTube channel, same place, and can't wait to see you guys there. Also, you'll also notice in the top right-hand corner, we're now on all podcast platforms. We've got a Space Door podcast, which is super exciting for us. So go check that out on wherever you listen to your podcasts, Spotify, Google, Apple Podcast, and you can catch all of the space roundups and all of the space talks on the different podcast platforms. Once again, it's been an amazing show, Nick and Terry. Thank you guys for doing this. It's amazing as ever. And everyone who's tuned in tonight, I hope you guys have enjoyed it. Have a great evening, and hopefully tune in on Thursday at 7 p.m. for serial space entrepreneur Mike Lawson.
Mike's a great guy. I'll round up and echo what Latcher said. Mike, we've done dealings with Oxford Space Systems. They're based at the Harwell campus. They do a thing called SAR, synthetic aperture radar. They've got some amazing work in that. Definitely really interesting guy, well worth listening to. I know you've got talks on mega constellations and all sorts. Tune into these shows and support these shows. Are really good. In response to some of the questions, somebody asked, is it Miles Carden? Yeah, Miles Carden is one of the people. Melissa Thorpe is now in charge at Spaceport Cornwall. Huge thank you, as Latch was saying, to, it's nice to see some familiar names and faces in the audience. Thank you so much. We're getting on average about 300. I think we've got 380 subscribers now to the various podcasts that you guys are doing. So it's great, and it's just growing and growing. And massive thank you. We're not social media influencers. We're not like Kim Kardashian where we've got 1 million people. But I've always come away from these things thinking, if one person goes away from anything we've said and gets inspired to do something with space. Somebody said the other week, I've been watching these shows for the last year, and I've taken on an Open University course on the back of it. That to me is outreach in its absolute entirety. So please tell your friends, kids, whatever. I know everyone's sick of Zoom, but we're trying to do something a bit different and a bit fun. And we've got great support, and huge thank you. So. And
we have somebody from America, Mary Ringler. Great to have you, and hope we'll see you again sometime. So I totally echo what Nick and Lax are saying there, and we love doing it, and hope to see you all again in 2 weeks' time.
Yeah, 417 subscribers now.
Wow, brilliant.
Yeah, we've hit the 400 mark. So if you aren't subscribed already, subscribe to our YouTube channel to support our growing space community. Just a question from St. Alex: is there an email list? Yes, you can head over to our website, scroll down, and join our mailing list. And we send out mailers every so often, telling you guys everything we're doing across social media. So yeah, join that if you haven't already. Ground-Based Space, thank you for joining us. And yeah, I hope you guys have a good evening. We'll wrap it up there.
Everyone,
okay.
Cheers.
Cheers. Bye-bye. Keep looking up. Bye-bye.